Decrypting the mitoribosome. Before we dive into the mitoribosome, first we must look at the cell. Here you'll see Nicole drawing some very important components of the cell, including the nucleus, the endoplasmic reticulum, the mitochondria, the cytoplasm, and ribosomes of the cell. But let's take a little closer look at the mitochondria. The mitochondria is classically known as the powerhouse of the cell. This is because the mitochondria is responsible for making ATP, which is where we get the energy in our bodies. You might be noticing that the membrane of the mitochondria is folded in a very particular way, forming cristae. These folds are very important because they allow the mitochondria to fit more of the machinery that produces ATP. Let's dive in a little deeper to see where they come from. Ribosomes are responsible for making the proteins that are essential to our bodies. While the cell has its own ribosomes, the mitochondria also has ribosomes specifically catered to its needs, which is lots of proteins, to carry out its ATP-producing responsibilities. It does so by a process known as translation. In translation, the ribosome first sandwiches itself onto the mRNA that it will be translating. The transfer RNA will bring an amino acid that it is tethered to into the aminoacyl site, or A site. This serves as a point of entry for the amino acid. It moves onto the peptidyl site, or P site, where the amino acid gets added to a chain formed by other amino acids. Lastly, the empty transfer RNA will move onto the exit site, or E site, where it will exit now that it has completed its task. The amino acid that is added is based upon the three grouped nucleotides in the mRNA sequence. In the same way that one language can be translated to another, nucleotides from mRNA will be translated into amino acids, which are the building blocks of proteins. Now that the protein has been made thanks to the mitochondrial ribosome, the protein can make its way to the membrane of the mitochondria. In the mitochondria, there are several complexes that work together as a pathway called the oxidative phosphorylation pathway. The most notable component is called ATP synthase, as its role is to produce ATP and thus energy. Without the mitochondrial ribosomes, we wouldn't have all the pieces to make this pathway, so we wouldn't have the energy needed to do fun things like play basketball, go biking, or flying a kite.